So today we'll discuss another passive element, that is capacitor. So capacitor, as per the definition, we call it as two conducting plates separated by dielectric material. Two conducting plates separated by dielectric material. And the formula for this is C is equal to epsilon A by D. Now A is the area of the plate. A is the area of the plate, and D is the distance between two plate. D is the distance between two plate, and this term is nothing but it's a material constant, which is nothing but relative permittivity. Now the permittivity of the material is very important in the deciding the value of the capacitance, because depending upon the material which is being used inside these two plates, which determines the value of capacitance. Let's say if it's air only, then the capacitance value will be different, even if we have a fixed distance and same uh, the area of the plates. But if we change the material within the uh, this area, I mean within between these two plates, then the capacitance will change. Now we'll try to understand that how it will change, because this permittivity will play a very important role. So what exactly the permittivity? So permittivity is for the material. Permittivity is for the material, and generally it is being expressed in terms of relative permittivity. So what the permittivity is? So if we assume that there is a air here, and in the case of air there is a the molecules are there which having a random orientation of a molecule. So maybe plus here, minus here, plus here. So it's a random orientation, right? Now the moment we give electric supply or electric field to that, the then uh, they'll align the this charges in a particular direction, which we called as a dipole. In this case, let's say this is properly aligned, dipoles are properly aligned. Now in that case, what will happen? It will oppose the flow of electron or electric field, and as a result, it provides a kind of resistance. It provides a kind of resistance to electric field. So this is just a basics, and if we talk about the material inside these two plates, let's say if we have a air. Now in the case of air, it is having a permittivity approximately at 1. But if we keep on, if we let's say there are different material, and let's say if we have a water, then water is having a permittivity is around 80, approximately 80 or 90 is there. So let's say if two conducting plates separated within the water, then if we measure the capacitance will be higher. But if, let us assume that it's a tank, and if we are measuring this capacitance of the tank, now in that case the uh, capacitance will be higher. But if water is empty, now in that case air will be there within that, and then the capacitance will reduce. So it can be used for measuring the level also, depending upon the material which is being used within the particular vessel. Now we are interested in understanding another term, that is relative permittivity. So relative permittivity is nothing but it's absolute permittivity divided by permittivity when the permittivity of the vacuum, right? So it's a ratio of this two, which is called as a relative, and relative is with reference to the permittivity of the vacuum. So this is just a deep dive into the theory of understanding that how permittivity affects the capacitance value. Now we are not, as of now, in terms of electronics, we are not interested into the theory right now, but we want to understand the functionality of the capacitor when we apply AC voltage and when we apply DC voltage. This is what we want to focus more. Now in this case, let's say we have a capacitor, and this is what we are giving a supply, external supply to the capacitor. Now let's say we have a DC supply, and let's say this is 5 volt DC supply. So naturally the flow of current will be like this, and let us assume that the negative electron will be here, so negative will be here and positive will be here, and current flows in the opposite direction of flow of electron. Now capacitance values are generally represented in terms of farad, microfarad, nanofarad. So unit is farad. Unit of capacitance, capacitor's value, that is in capacitance, is measured in terms of farad. Now let us assume that this is having one particular value of microfarad or farad. We are not concerned with the value as of now, but we are more concerned with the another term which is useful here. Now in this case, the first question is, does the current will complete the loop and will flow inside the capacitor? The first question. So in this case, when we apply this DC voltage, now in that case, as we have seen that due to the permittivity and alignment of the dipole, it will oppose the electric field. And as a result, what will happen? The current will not pass through these two plates. Current cannot pass through these two plates. That means current cannot flow or complete this circuit when we apply DC voltage. Now what will happen in that case? It will keep on accumulating the charges. It will keep on accumulating the charges. So in that case we can say that it stores charges. So capacitor store charge, and there is a specific formula for that. I think 1 by 2 CV square, that is the energy. 1 by 2 CV square is the energy stored. Now in this case, let's say, let us assume the value of capacitance for this case is 0.1 microfarad, right? Now the value of supply given is 5 volt DC, and value of capacitance is 0.1 microfarad. So if you want to if you go to the market and want to buy the capacitor, what how will you address to the shopkeeper? Will you say that give me zero point 0.1 microfarad capacitor? Is it like that? So it is not like that. So you have to be clear that I want zero point 0.1 microfarad capacitor with voltage rating. This is more important. The most important is voltage rating. Now how this plays important role? How this voltage rating plays important role? Now let us say we have a capacitance for our theoretical understanding. We are assuming that value, that this is zero point 0.1 microfarad, 1 volt capacity. So it indicates a capacity. It indicates a capacity, means this capacitor can withstand up to 1 volt. As of now, let's say we assume the capacitor which we have connected, it is having the capacity of 10 volt. As of now, for theoretical purpose, we are assuming that this capacitor we have connected in this circuit is of having capacity to withstand charge up to 10 volt. Now in that case, what will happen? The voltage you have given is 5 volt. Capacitor is 0 0.1 microfarad, and the charge it can withstand is whatever the voltage here can be withstand by this capacitor. So all this 5 volt will be accumulated, will be here, and you can, if there is a switch, if there is a switch, if you open this switch, then the same 5 volt can be measured over here. The same 5 volt can be measured, and it will slowly decay depending upon the discharge resistance, and other circuits are there. So we are not concerned about the other circuit, but let us assume that this is the case. Then ideally or theoretically the whole 5 volt will be stored in terms of energy by this capacitor. Now let us say if we reduce this voltage capacity, instead of 5 volt, instead of 10 volt, if we make it, let's say, less than 5 volt, let's say 2 volt, that means what? The capacity of this capacitor to hold the charge, I mean voltage, with a capacity of 2 volt, and what we are applying is a 5 volt. What we are applying is 5 volt. So let us say that initially it will keep on accumulating the charges until 2 volt it will hold. The moment the voltage increases above 2 volt, the moment above increases above 2 volt, in that case what will happen? The charge accumulated will be more here, greater than 2 volt. So this positive will attract this negative. This positive will attract this negative, and due to that there is a flow of, or you can say exchange will take place. So there is a flow of current will take place, because this positive attracts this negative, and it will rapture, it will rapture this, and it will uh, try to flow the current from this two plates, between two plates. This phenomenon is called as a explosion of capacitor, or blast of capacitor. So the most important or thumb rule is, whatever voltage you are connecting, at least 10 times more voltage rating capacitance should be selected. It's a thumb rule. It's a thumb rule. It may be 5 or it may be 10, but generally the thumb rule is, for a safety purpose, it is more than 10 times. But you have to pay a price for this. If you go for 5, lesser price. If you go for 10, more the price. Right? So the price has to be paid in terms of, so more the safety if you have a 10 volt. So safety is directly proportional to the price. So thumb rule says that 10 times. In electronics, the thumb rule says the 10 times. Now, in this case, the inductive, capacitive reactance, or what we called it as uh, resistance offered by the capacitor. Resistance offered by the capacitance or capacitor to the flow of current. Now in this case it is very simple, that when we apply a DC voltage, it's an infinite resistance is being offered. When we apply DC voltage, infinite resistance is being offered. Now what do you mean by infinite resistance? In so ultimately this is being expressed in with reference to frequency, because this behaves differently in terms of AC as well as DC, and it behave differently when frequency is increasing, right? So generally it is expressed in terms of XC is equal to 1 upon 2 pi FC, or this can be called as a omega, right? So this F is 0. F is 0 means what? It's set in the denominator, so this becomes infinite. So in the DC, this offers infinite resistance. In DC, it offers infinite resistance. So this capacitive reactance is infinite in case of DC. So generally, this capacitor is being used when you make a when you use a power, when you design a power supply circuit or something like that to hold the voltages sometimes. Clear? Now let us say instead of DC we provide AC voltage. Instead of DC we provide AC voltage. So AC is nothing but its alternating voltage. Now in the case of alternating voltage, let's say in the positive half cycle, so during the positive half cycle, this is negative. I mean less the potential here. So positive voltage here, right? And this is negative. But during negative, in another half cycle, this becomes negative, this becomes positive. Now in that case, there is an exchange of the charge takes place. Because of the change in the polarity, there is a exchange of charge takes place on the plate of the capacitor, right? So on the terminal of the capacitor. So what will happen? It's nothing but it's a flow of current. It's nothing but it's a flow of current, but it cannot store the uh, current. Now in that case, if you see the waveform over here, then you may find charging and discharging kind of waveform here, because of the exchange of the charge takes place and you cannot have a steady voltage. Clear? Now if we try to understand the same phenomenon in case of AC for capacitive reactance. Capacitive reactance. Now in that case, we'll use the same formula, right? So in DC F was 0. In DC F was 0, so Xc was infinite. That means no current can flow through the circuit or current cannot flow through the capacitor. But in AC, there is some frequency which is always greater than 0, and hence there is exchange of charge take place and there is a flow of electron or flow of current, what we say. And as a result this Xc is not infinite, but it is having some value. Now if frequency increases, then this Xc will reduce. Frequency increases, then Xc will reduce. Now in that case, more fast exchange of charge takes place, and as a result we can say that there is a less opposition for the flow of charge. It's a less opposition for the flow of charge. Clear? So this is how the behavior of the capacitor in terms under the AC as well as under the DC, right? So the most important point which you need to remember about this thing is, number one is a permittivity, then area, distance between two plates, area of plates, distance between two plates, because this plays very important role. And in fact all of this plays very important role in deciding the value of capacitance. And there is a different behavior in terms of DC and AC, because in DC it behaves in a differently, totally different. AC it behaves totally different. But yeah, most important is its voltage rating. Most important is voltage rating. So if your capacitance is less than the supplied voltage, then there is a possibility that it gets blast. Not only possibility, 100% it will get blast. Clear? Thank you.